In this 10th lecture on Fortran, we shall continue our discussion on user-defined function. We want to make a subfunction which will give me the median of the number of data. This program is a bit complicated one, so I will explain you step by step. In the last lecture we were considering, towards the end we are considering a program to calculate the maximum of a set of data. The program was right, but I forgot to explain the functioning of the program. In some way it is good, because none of you has ever asked me a question except one. So by this may provoke you to contact me. Now come to the program that to calculate the median. You know the definition of median. If you have a set of data, then you first arrange them in a order, either in ascending order and descending order. Then leave maximum number of data from the beginning and from the end, so that you are left with at least one data. If the number of observation be odd, n is equal to odd, then we can write it as 2m plus 1, and then you leave m data from the beginning, and you will have m plus 1 and then m data towards the end. And this, after sorting, m plus 1th data will be the median. And if n be even, then we write it 2m, and you leave m minus 1 data from the beginning and m minus 1 data towards the end, so you are left with m and m plus 1th data, and the arithmetic mean of these two is the median. This is the theory of median. The main part is there to arrange the data. So the program, I am keeping entire botheration on subfunction, so we call dimension in the main program dimension n, the number of dimension of x, say it is 200, then read n must be less than or equal to 200, and then read xi, I is equal to 1 to n, then write median. So this is the main program. It reads the number of data to be handled and the n datas, and then asks the daemon r median. R is written so that the quantity is real, and asks this daemon who will take number of data and the data's corresponding data, and will calculate the median. Sorry, I have several times I have used the word datas. This is wrong, because data itself is plural, its singular is datam. But this as a slip of tongue I have told several times datas, but it's data. Now come to the subfunction. nx. Now, if we are provided with n data, then there are NC2 distinct pairs. We are to make a comparison with NC2 pairs. How to create this NC2 pair we have learned in our discussion with do loops. So we do such a do blank 1 blank I is equal to 1 to n minus 1, do blank 2 blank j is equal to I plus 1 to n. Then we are I ranging from 1 to n minus 1, j ranging from I plus 1 to n. So if we have say n is equal to 3, then I is first value of I is 1. Within this I, j assumes the value 2 and 3. Then the second value of I is 2 and j value will be simply 3. So there are the pairs are 1 2, 1 3 and 2 3. So this is 3c2 3 2 2 1 is equal to 3. Sorry. If you have n is equal to 4, then we have so we'll add 1 2 3 4 5 6. So 4c2 is 4 into 3, 2 into 1 is equal to 4. So it creates the data. Now what we do? Here if we consider xi and xj, then we have xi and xj. Now our aim is to first to fix what we want to do. Do we want to arrange them in ascending order? Means the ascending order means the lowest one will be on the leftmost end and the largest one on the rightmost end. If you want to arrange this in ascending order for sorting order, what we do? If xi less than xj, keep the pair in, keep the pair unchanged. If xi greater than xj, exchange the pair. This is the exchange the pair. This will sort the data. Say for example, xi is 2, xj is 5. Then this is already in order because we want to sort them in ascending order. So it is already in order, so you need not to do anything. But if the thing is reversed, say this is 5 and this is 2, so this is not in right order. So we are to exchange them so that xi becomes 2 and xj becomes 5. Now let me show how can it be done. xi less than xj, then what we shall do? We shall do nothing. Sorry, do it greater than it. So if xi is greater than xj, it is not in right order, so we want to exchange this. So we call here actually xi was 5 and xj was 2. We want to make xi 5, so we write xi is equal to xj, so that xi becomes 2, and the value of xi is kept in a temporary destination, and we write xj is equal to temp. This is the logic. So temp is equal to xi, then so this is xi is greater than xj, so xi is 5, xj is 2. So what we do? First we define temp is equal to xi, that is equal to 5. Xi is equal to 5. Then we write xi is equal to xj is equal to 2, because xj is 2. Xj is 2. Then we write xj is equal to temp. So at there xi is 2, xj is 5. This is the working of the program. Then this is and if, else part you need not to do anything. So after this line, the data will be sorted in ascending order. If you want to check, you write it will give you the sorted data. Now we are to find out the median. So first we need to check whether n is even or odd. From this we write m is equal to mod n by 2. So this is the remainder, means remainder when n is divided by 2. If n is an even number, then m is 0, and otherwise it is 1. So if m equal to 0, here since m is integer, I am not putting 0.0, then so n is even, so n is equal to 2m. So we need to find out m. So m is equal to n by 2. So the our median first we write m. We call it L because L is again by 2, no point. divided by 2 point. So there are 2m data, so we leave m minus 1 from the left and m minus 1 from the right. So this number of data is mth data and m plus 1th data. This is mth data, m plus 1th data after the sorting. And in the else part, we will arrive when the data number of data is odd, and we write m is equal to n minus 1 by 2, because we write n is equal to 2m plus 1, so m is equal to n minus 1 divided by 2, and our median this is the working of the program. So what it does, first this main program reads the number of data to be handled and the actual data. Say n is 5, then it reads x1 through x5, and then it calls the daemon rmedian, which takes n and xi as input, x as input, and calculates the median there, and the program stops here. Here comes the subprogram. The subprogram names r median. R is added so that the median is a real quantity. Its input is number of data, and the data itself, same dimension has to be used. Then it creates the NC2 pairs. There we by these two do loops. And if so, here I missed one, first 2, then 1, these are continuous, so better to remove this line from here. 2 continue, 1 continue, write the sorted data, okay. Then it creates NC2 pairs and compare the data xi and xj. If xi is less than xj, then else part is not there, so it keeps the pair intact. If xi is greater than xj, since I is less than j, then it just swaps the data xi and xj. Then these loops are completed and we write the sorted data. Then we come to the identification of whether the number of data is even or odd. If it is even, then this is the definition of median, and if m is odd, then this is the definition of median. One point I want to make clear: if we do not do this, what will happen? In that case, as example I have taken xi is equal to 5, xj is equal to 2. In the first step I write xi is equal to xj, this is equal to 2, so xi is 2, and now I write xj is equal to xi, it is again 2, both of them would be 2. To avoid this, the value of xi is kept within temp, and whenever you write this, not xi but temp, you get the right order. So it is 5. It is in the right order. So this is the working of problem. The last example I am going to consider is the calculation of factorial, which is very often occurs in the evaluation of e to the power series or sine, cosine terms, cosine and cosine when we use the Taylor expansion. Consider that we need to calculate S is equal to summation over I is equal to 0 to say n, where n will be supplied beforehand, xi by I factorial. That is, the series is basically 1 plus x square by factorial 2 plus x cube by factorial 3 up to x to the power n factorial n. Now, the program need to know only the value of x and value of n. So the program first reads this. For the sake of to reduce truncation error, keep n less than 10. Do not go over this because factorial of n is a huge number. I will show you afterwards how to manage such functions, such terms. Then we try with sum is equal to 0.0. Then do blank 10 blank I is equal to 0 to n. I is equal to 0 to n. Term, the term means this term, the ith term is x to the power I by factorial I. So we write x double star I by fact I. Sum is equal to sum plus term then continue and then we write n number of terms x and s. Now we come to the subfunction, function fact. We know that factorial of 0 is 0, factorial of 1 is 1, and we can calculate the factorial of negative integers are not defined. So here we are considering the factorial of an integer. So if we write then factorial of negative integer is not defined. Keep a warning that 72 columns should not be exceeded. Then stop. I make the program stop. Done. fact is equal to 1.0. Do blank 10 blank I is equal to 2 comma n should I 10 continue. So how does the program work? It takes firstly it takes the value of I is equal to 0. It calculates x to the power 0 is 1, then fact of 0, then it goes there with 0. First it checks whether it is negative. No, it's not negative, so it comes to, since it is not negative, it comes directly to this. And then the do loop is 2 to 0 in steps of 1, so the do loop does not work at all. So basically the program from here with n is equal to 0 comes there. Here the fact is 1, so it returns the value of fact as 1. If in the next step I is equal to 1, it again comes there, and this doesn't work at all, then again it returns fact 1 is 1. With fact is equal to 2, it comes there, and as it takes only one value, so it is already 1 multiplied by 2, so it is 2, and it returns the factorial value as 2, and this way the program continues. But remember that factorial 10 is a very large number, and if you want to calculate this in this fashion, say more than 10 to 12 terms, the entire calculation will go wrong. I will show in a future class how to tackle such things. Then we are to take a big recursive relation, that is, we will never go to the factorial definition. Say ti plus 1 is equal to xi plus 1 by I plus 1 factorial, and ti is xi by I factorial. So ti by ti plus 1 by ti is so this is x by, in which case we write ti plus 1 is equal to x times ti divided by I plus 1. This is the recursive relation that is used with t0 is equal to 1. So t0 is equal to 1, I is equal to 0, I is equal to 0, t0 is equal to 1. So when we come to t1, you put I is equal to 0, so t1 comes out to be x times 1 by 1, this is x. Now t2 is equal to t1 times x by 2. So this is x square by 2. That's why the terms are in. Now come to the t3. T3 is equal to t2 times x by 3. So this is x cubed by factorial 3. That's why the number is the recursive relation is used to develop one term from a knowledge of its preceding terms. And in this case, you can take in, say, up to 10,000, and no appreciable error will be introduced.